All right, so in problem 3, we're asked to find for both shapes the length of the apothem and the area of the shapes. So remember that the radius is if I put a point in the center and drew a line straight to the vertex, that would be my radius. See if I can refocus this real fast. Sorry. Okay, and then my apothem is like if I have two radii, the apothem's between them, and it gets it hits the midpoint of the side and it's perpendicular to the side. So just like we've done in class, I like to kind of draw the radii in, and I see I have 1, 2, 3, 4, 5 big isosceles triangles. So I'm going to divide 360 degrees of arc by my 5 triangles, and I get that each triangle has 72 degrees in it. So I'm talking about the isosceles triangle. Those are the radii, and it's 2 feet. When you drop the apothem, it makes a right triangle. So this is my apothem. This is now half of 72, so 36, because I'm just looking at half this triangle, and this is now a 1 instead of a 2. So if we want to find the length of the apothem, we have to use a trig, and we have to use the tangent function because we don't know the hypotenuse, that's the radius. We know the opposite side, and we're looking for the apothem, which is the adjacent side. So the tangent of 36 degrees is equal to its opposite side divided by its adjacent side, which is A for apothem. When the variable's on bottom, we can swap our we can use swap our extremes. And so I can put A by itself and do 1 over the tangent of 36. Otherwise, you can cross multiply, get the same thing. All right, make sure your calculator is in degrees, not radians. And you're gonna do 1 divided by the tangent of 36. So that gives us the length of the apothem, which is about 1.376. Don't forget units, it's in feet. So then when we find the area, I'm going to go back to the triangle. The height is 1.376. The base of the isosceles triangle is 2. We know area is base times height divided by 2. So 2 times 1.376 divided by 2 just gives us 1.376. So that's my area. That's of the triangle though. That's not of the pentagon. So once I get my area of the triangle, I want to multiply that by 5 because there are 5 triangles. So I'm going to take that, multiply by 5. The area of my pentagon is 6.882. So approximately 6.882 square feet. All right, number 3, really similar, except it's a hexagon. So I know I've got 6 triangles. So 360 divided by 6 is 60 degrees. You could actually do a 30, 60, 90 here. It's tricky because you're given not a even number for the length, but that's okay. So if this entire angle is 60 degrees, when I sketch my right triangle, that top angle is now 30 because I cut it in half. The side is 3.5 inches, and we're still finding the apothem first. We have the same information, so we're still going to use tangent, or you could use your special right triangle pattern and just multiply this by the square root of 3. I'm just going to use tangent though. Tangent of 30 is 3.5 over A. Therefore, the apothem is 3.5 divided by the tangent of 30. So if I do that in my calculator, and notice that's the same as if we had multiplied that by the square root of 3, which we learned in unit 2.4 how to do. All right, so the length of my apothem is 6.062 inches. All right, so then when I find the area of my triangle, I'm going back to the isosceles. The base is 7, the height is 6.062. I'm going to do base times height divided by 2. The area of one triangle is about 21.218. And since it's a 6 hexagon, we're gonna multiply that by 6 to get the total area. So my total area is 127.306 square inches. Don't forget about those units. All right, let's look for some of the ones on the back. They're gonna be in a separate video.